I'm Alex Shore, managing partner at Gridvest. We are a battery storage distributor and financing company, and I've been very excited to be able to be up here with some amazing panelists who we'll introduce in a moment. And today is really about power users, power generators, and how to deploy battery storage at a larger scale. So we just heard from the DER and VPP side. That's a very nice segue into what we're going to talk about, which is just some of the same challenges, just slightly larger scale. And how do you make batteries work in reality for behind the meter, front of the meter, and off grid? So with that, yeah. So again, just real quick background on me is that I lived in China for 9 years. Built a solar business there, folks doing the first PPAs in China, and then came back to the US and saw that battery storage was about to do the same thing that solar had just done over the last 10 years and started Gridvest. Our big thing is about financing battery equipment and distributing that equipment, making it more accessible. And we're brand agnostic, so we source from all the tier 1 suppliers, but bundling it all, battery, inverter, and EMS. So that's my background. I'm gonna hand it over to my colleague Sam for a quick intro.
Yeah, great to be here. I shout out to 90. I work here 2 days a week upstairs, so it's a great space. Yeah, so I'm Sam Maslin. I'm the CEO of Eddy Energy. Eddy is a relatively young, time flies, like 2.5 years ago we were founded, and we're a developer of what we call community scale energy storage projects. So I listened to a little bit of the last panel. It's going to be some overlap, hopefully in a good way, kind of like maybe our asset class is like just the next segment up from aggregations and VPPs. So our projects are typically 3 to 10 megawatts, and as maybe we'll describe, we're really all about kind of improving the distribution grid. So great need and opportunity to put assets on our distribution grid, and that's what Eddy Energy is. I actually sort of cut my teeth working at Recurrent Energy as a solar developer, literally next door. So I've been kind of in the space and in solar for probably too long at this point, and yeah, happy to be here.
Hello, my name is Adrienne Pierce, and I'm the CEO of New Sun Road. We have a slightly different take on all of this. We have a control and energy management platform for microgrids or energy power systems. We have about 1,500 systems on the platform, everything from small systems that are doing critical infrastructure like telecommunications towers to working with PG&E and being their aggregator and remote monitoring for their remote grids, to doing a lot of C&I work, also doing things in the resilience sector. So for us, it's all about interoperability. We don't really care who's generating the power, what the storage looks like, and what the load looks like, but we're just trying to make it all work together in the context that is needed for that particular moment, because that also changes, as we were sort of heard from the last panel. And yeah, and that's what drives us.
And I'm Sean Gallagher. I'm the Senior Vice President for Policy at SEIA. SEIA is the National Trade Association for the Solar and Storage Industries. I oversee all of our state and federal policy and advocacy work. SEIA, of course, started out as the Solar Association about, something less than 10 years ago. We added storage to the portfolio, all the more so now with, after the passage of the one not very beautiful bill last summer. The storage credit persists, the solar credit starts to tail off. We're putting a lot of energy in, sorry for the pun, into storage this year. And I'll agree that there's going to be a lot of synchronicity between this panel and the last one. Some of our priorities this year are enabling VPPs, enabling front-of-the-meter storage and solar procurement, et cetera, et cetera. So it should be a good panel. Thanks.
Great. Well, really good. I think we're going to have a great conversation today. And I think just to tie it all together, because we have 3 very distinct kind of different personas up here, right? We have a developer working on the front of meter, 3 to 10 megawatt community scale. We've got a microgrid controls company that is really the kind of the brains or the backbone of a lot of battery storage projects, especially if you need backup power or off-grid operations. And then we have a facilitator or a policy organization that's really helping to just grease the wheels of progress and helping to move policy and data and companies forward, I would say. So I think it's a really nice, unique perspective here. And I think one of the biggest growth areas in battery storage from a percentage perspective is the smaller front of meter space. There's many categories of what fall under that, but that could be a distribution level grid. It could be a community scale project. So I want to start there because I think that sets us differently a little bit from the last panel, which was more distributed and behind the meter. Let's talk about what does community scale storage look like right now, and what are other kind of front of meter, smaller front of meter, not the massive utility scale projects that how do you see it, Sam? And tell me about what you think is the future of that and how Eddy Energy is playing in it.
Yeah, definitely. I mean, there was this good, I forget who, some blog post I read, or an article a couple of months ago that said basically, is it not loud enough? 15 years ago, DERs, net metering was kind of cute, wasn't really addressing a system need. It was people could say they were green, which is all well and good. And it's sort of now the system needs DERs. So starting Eddy was really a recognition of, just the kind of the need we were seeing. I think there's a lot of things that the previous panel mentioned. I think one thing that really struck me was I saw some analysis of California bills, rates, and as we already know, those are very high already. 60% of the total component of the bill is the distribution infrastructure costs, which is pretty gigantic, and actually was projected to grow to 70% over the next 10 plus years. And that's a share of something which is itself, unfortunately, friggin' skyrocketing. So I think more and more people, when you hear stuff in the news, it's kind of a steady drumbeat at this point, VPPs, the potential of load flexibility, kind of what our segment would call maybe the larger DER community segment. I view all of those as kind of one umbrella of attacking that 60 to 70% of the bill. And I think there's a really great opportunity. I think we're, sort of, not to be too glib, but basically everybody agrees at this point that it's not just some cute idea. We need a lot of distributed assets to improve the system. There's, I think, the nature of the grid is that you generally, I mean, the last panel talked about load and kind of trading energy. If you're installing a larger asset that's trying to help the distribution grid, you generally can't really access that directly. You need some sort of a framework or a program to sort of get that value, whether it's some of the programs they have in the East Coast, New York VEDR, some of the stuff in ISA New England, or other states where it's essentially a long-term IRP-driven target that the utility is then going to procure. But I guess I would say a lot of bullishness about the space. I mean, I think seeing kind of this overall the larger DER umbrella from VPPs, responsive load, up to 5 megawatt batteries being something that's really taking off. I would say, unfortunately, as a proud Californian, we are literally the backwater at this point, and it's our CPUC just hates DERs. That's literally true. So other states are, not all states are really getting there. In my opinion, not maybe every single thing about California, but a lot of stuff is not very good.
You're pretty much right.
Frankly, I guess I would, to answer your question, there's a lot of different ways to get there to kind of realize that value, but more and more people are recognizing we have a lot of needs in the system. We have, spiraling costs. We have EV charging hub is getting told it needs to wait 5 years to come online. So I just think the need for DERs to solve real system problems and not just be this cute thing that advocates pushed through 15 years ago, I think it's pretty universal. And I think state by state, we're kind of enacting programs to try to get there.
Great.
Yeah, I mean, I completely agree. I think you're absolutely right about the value that sort of that class of up to 10 megawatt DERs, whether they're storage only or solar and storage, can provide to the system. And also absolutely right that the trick and the thing that we got to focus on is how do we enable these? What's the market mechanism? Is it a retail-based market mechanism? Is it a wholesale-based market mechanism? Because they're not, you can't just throw it on the system and take market revenues, right? You've got to have a program in order to facilitate these things. And the system's going to need it. We got to figure out what those systems look like.
Yeah, great. That's a great point. And now just to kind of switch back into Adrienne, I want to kind of pull you in for a second. Tell us a little bit about how microgrids fit in here, because for me, that's the ultimate use case of battery storage, right? And obviously there's grid elements in terms of the benefits. There's benefits of not even needing a grid at times. So tell us a little bit more about your perspective in terms of large scale battery storage deployment and where batteries meet reality in that way.
Yeah, good question. As the conversation was going, we're talking about the future, we're talking about all of these programs, but the need is now, right? There are people right now who want to expand their businesses. There are people that are worried about power outages. There are people that are working on wildfire mitigation. And so while we're waiting for these programs and these policies, and our system is slow and it makes sure that it's very careful and it's got its hiccups and so forth. But what microgrids do and what our technology allows you to do is to take advantage of what's going on now to meet the needs and then to adapt as things change. So what does that look like? It looks like bringing in battery storage, having it be available, and having your system be zero export. So you're consuming on site, you're meeting the requirements of the grid because they won't give you an interconnection permit unless you meet certain requirements. So you need to guarantee zero export. But now the grid doesn't update and they now want to tap into your battery because they want to do demand response a couple of years from now. So that's where the interoperability and the flexibility. Somebody had asked me earlier, like, do we need more software? We just need software that talks to each other better. And it needs to be flexible enough so that it can really look at the context of what's happening and take advantage of that value. So that's where the controls architecture really can deliver what the battery systems are offering. You've got generation, you've got storage, you've got load. From our perspective, we look at storage, we look at battery storage, we look at thermal storage. We have a project where in Mozambique where they're making ice, which is a form of thermal storage for a fishing village, if you think about it that way. So there's lots of ways to contextualize this. And then if you can get it to all work together, then you can unlock the value at scale for a VPP or for the local user so that they have the resilience that they need for critical infrastructure, say in a rural health clinic or for wildfire mitigation. So what I really like about what we do is that capability and capacity and that real tangibility associated with it. So I kind of went off on a...
No, I think that's helpful. And I think just to go one level deeper, I mean, do you think that, where do you see off-grid fitting in? Like, do you see people saying, I don't need the grid, or I don't have a grid, and so I need to build something?
Well, it's interesting that you say, I don't need the grid. Most of the people that we talk to don't really want to be off-grid. They're either off-grid because the grid hasn't gotten there yet and it keeps promising that it's going to get there. Or in certain cases, like in Texas, where they're saying that, if you're over 75 megawatts and the grid is unstable, they have the right to sort of shut you off, right? So there's a dynamic also tension going on between the utilities and people who are there. So the interconnection lines and the delays associated with that. So there's a lot of people who are using an off-grid or an islanded architecture to bridge as we get to where we need to be. So this is what I'm talking about, unlocking the benefits of batteries in real time for the user right now, but then also being able to play in what it's going to look like 5 to 10 years from now.
Yeah, great. Anything to add on that before I go to the next point? I think it's well summarized. So Sean, over to you for a second. Can you tell us a little bit more about what you're seeing from a SEIA perspective in terms of how, like, just we've talked about utility side and we talked about a little bit about the commercial side. What do you think we need to do to unlock more storage, like from a SEIA perspective, from your perspective personally as well, and how do we make it just more commercially viable to deploy storage?
Yeah, so I mean, people like these guys who are making the economics work and the actual projects work, I think we're trying to create the conditions under which these projects can get built and will get built. So things like, so we put out a storage target last year of 700 gigawatt hours by 2030. That's about a 50% increase over what the business as usual projections would have shown. And how do we get to that 700 gigawatt target? I think we're going to do about 70 gigawatt hours this year, right? So that's less than 20th, 1/5 of the time we have left. So we got to increase that over the next couple of years. And so how do we get there? Sort of 3 buckets that we put our policy work in, our advocacy work in, includes leveling playing field. So that means like treating interconnection, compensation mechanisms, treats storage like any other resource, allow it to get on the grid, enable flexible interconnection, enable compensation mechanisms that allow storage resource to take advantage of all the different services that they can provide. Level playing field, compensation. Some of that is still upfront incentives in places like New Jersey, Maryland, many of the East Coast markets that don't have the same kind of market dynamics that California and Texas do. You still need something to grease the market to get it going. So we're working on those kinds of programs. And then domestic supply chain. We recognized, 5 or 8 years ago that in order to have the policy support we need from policymakers for the solar industry, we needed to sort of transition away from a supply chain that was, at that point, largely based on China, have more domestic manufacturing, create that sort of groundswell support. Same is true on the storage side, all the more so since the imposition of the FIAC rules last year. And I think the good news is that the storage supply chain is getting built out in the U.S. right now. Some of that is a result of the ending of the EV tax credit, as you see battery manufacturers shifting to stationary storage manufacturing. But that's good news. And so those are some of the key things that we're working on this year.
Yeah, that's great. No, I think we see a lot of that at Gridvest as well, and we appreciate all the work you guys are doing. Just to come back to the question around foreign entity of concern and domestic sourcing versus Chinese sourcing and also the in-between, which would be Korean or Japanese manufacturers, or even other Southeast Asian countries. I'd love to just hear from each one of you, like, how do you see that affecting your business today, and what's your general view of the next 2 years? Because I think by 2028, I think we can all probably agree that there's going to be enough of a domestic manufacturing market that it probably won't be much of a question. There's also going to be hopefully new administration, so policies will probably change. So we're talking really about the next 2 years. So if you're a storage developer, EPC, end user, and you want storage, any thoughts around on how to navigate that from your perspectives?
Yeah, I can take that first. I mean, first of all, I'm just going to make the comment, like, if I really hate the ITC. Like, if we could just blow up the entire ITC, like, because it exists as a developer, you have to get it. But it's a very kind of ludicrous kind of concept, in my opinion. So just throwing that out there. But as it were, like, the ITC for a storage developer. I mean, there is the case where you talk to people and there's the, let's go no ITC and just use, very, very low cost, kind of future, sort of Chinese produced batteries, but that's probably not the base case. And so, yeah, I mean, for us, we had our first projects are coming online at the end of next year. And we essentially had to, kind of a critical time of like, and we're kind of a young company, we're just kind of getting some institutional funding. And so do we try to safe harbor? And, we made the call that we're, a lot of people frankly get burned safe harboring for one reason or another. So we're not going to safe harbor, and we're going to kind of trust that the supply chain will be there. And, frankly, we still haven't made our technology selection for the Q4 27 projects. Or, I mean, I think generally people see, supply, and like I do as, an American, I like the response of, all these, fabrication facility in Kentucky and whatnot being open domestically. We see that opening up, and, then to what extent can we get domestic content and what are those rules? But I would say that overall, like, there's already enough uncertainty with like the inherent thing that we are doing, which we were talking about, which is the last panel was talking about, to add this whole other layer of like some tax equity investor's lawyer, signing off on like 5 years of reporting around whatever supply chain. Like, I don't know. I didn't get into this business to like worry about stuff like that. So I think it's like, it's an unfortunate evil. This is why I like to work with people like Alex, who knows this stuff. But anyway, I mean, I'd say like some cautious confidence, but it's just the comment that it's really not ideal. And like, let's focus on the energy and not like pay a bunch of lawyers and tax people. So
yeah. Anyway. And I just want to add too that I think your points are I agree with a lot of what you're saying. But the economics, if you're looking at like behind the meter or a CNI project, luckily I think those are actually at a point where you can go without tax credit more easily, I would say. If you're looking at where the electricity rates going up and different revenue mechanisms coming on from VPPs to frequency regulation to a lot of different, obviously demand charges being one of the main ones. So we're seeing, at least at Gridvest, a lot of developers who are saying, yeah, we're just skipping the ITC. It's too much headache, and we can make it work with a lower cost system. So, but anyway, I want to let others chime in on this topic if there's any thoughts around it.
Yeah, I mean, I'll say that the next 2 years, so 26, 27, was the timeline in which we were most concerned about the availability of FIAC compliant products once the bill passed, right? For just the reasons you mentioned. I would say between safe harboring and the sort of quick response of the supply chain, our concerns for this period have markedly decreased. When I talk to developers, what they tell me is that their suppliers tell them that they will have fiat compliant products available. And
they would say that. It's it's like, well, you could convince me, but can you convince you still have to be cautious. So we hear the same thing.
Yeah. So like the proof will be in the pudding, but I think that from what we're hearing, and we have a supply chain team that does its own sort of market intelligence. So we're not relying entirely on sort of third-party reporting, but it would appear that there's going to be, a sufficient amount of fiat compliant supply chain on the battery side, the storage side in particular, which is where the concern was, to carry us through the next couple of years. And then supply chain is only getting stronger. Now, if I can just quick comment on the idea of like using the cheapest Chinese-made products and skipping the ITC altogether, we're real interested in seeing how much of that there is. We are starting to hear about some of that. There will be some implications for domestic manufacturers if that becomes a wave. And so call us up if you're doing that. Let me know.
Can you elaborate really quick, just so I didn't understand the point? You mean that what's the concern? That if enough people start going to the Chinese manufacturing, that it would hurt domestic manufacturing?
Correct. Yeah.
Yeah. I think that. Yeah. My quick response to that is just simply that I think there's not going to be enough necessarily. Like, it might put pricing pressure on domestic manufacturing, but the demand for domestic manufacturing will be there. The question is, can they do it at the price that where it's like, oh well, if you can't do it at this price, then I'm going over here.
And between sort of tariffs and sort of structural differences in manufacturing costs between a place like the U.S. and a place like China, it's pretty difficult, even with the 45X incentives for domestic manufacturers to compete with global manufacturers, particularly out of China. They're never going to be able to compete, directly on price. But you're right. It's got to be close enough. One of our sort of forward-looking goals for probably the next administration is like, what's industrial policy 2.0 look like? How are we going to continue the support for domestic manufacturing for these industries?
Great. So just kind of jumping back into interconnection for a moment, I think that is an area we touched on already, but it's just so many pieces of the puzzle get blocked there or get held up there. And I think each state, there's so many different nuances. You mentioned already about California and some of the challenges, but I'd love to talk, let's dream for a moment. Like, what would be the idea? What's the dream here? What should we be talking about to our regulators and to our utilities about how to improve the interconnection process for storage, large-scale storage in particular? So I'd love to hear thoughts around what's the dream, a realistic dream, but a dream that might be within the realm of reality.
Yeah, I can speak a little bit to that. You've got the interconnection queue, which is very, very long, and then you have folks who have a large demand requirement like data centers, and they are looking nationally for opportunities, and so they are putting in requests at multiple utilities. So the utilities are seeing a dozen different requests, and they think, oh wow, I need to provide an additional 7 gigawatts of power, which isn't the case. And then you have smaller people who also want to do, the system is just overloaded. And until there is some way to rationalize things, and maybe AI can help, I don't know, but some way to sort of rationalize it, it's going to continue to be a bottleneck and continue to be something that slows the ability to deploy battery storage. And also, it just doesn't give you, you've got all of these projects that are sort of on the books and trying, not all of them are going to move forward. So how do you know where to build the infrastructure to support that? And, if it is just market economics, who has the most money and who can do it fastest, they're the ones who get to win. Is that really what is going to be best for for the country and for our infrastructure in the long term? And so, there's a lot of work to be done.
Yeah.
I don't have an answer.
Okay. Any other thoughts?
Yeah, I have a lot of thoughts on this topic. Sorry, I lost my train of thought. Well, I guess the DER community in general historically has sort of said, and this just is the way it works, we sort of want, or we frankly demand sometimes, like advocate for kind of the unfettered right, or like simple processes to interconnect, like boom, 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 boom. And then on the other hand, there's whatever like that's kind of like, it's one thing. And then sort of unconnected to that is the regime of market participation for DERs or net metering or whatever it is. And so these things kind of exist separately. I think in our space, as we're really talking about like the needs of the distribution grid and like putting on larger DERs, like I'm going to take the side of the utility for a little bit, even though we often push back, is like, well, if you're like showing up with like a 4 megawatt battery in like to a distribution circuit, you know, they're like, that's a really critical asset. They're going to be operating that circuit using your battery. And if you're, you know, we're arguing for this value stack all the time. You got to compensate us. And like, well, if you're getting that compensation, to me, that means, that almost inherently means that you're like resolving a constraint. Like you likely don't have something that can just be simplistically interconnected, because if you did, if there was like tons of headroom on the circuit, then you might ask the question of like, well, what's the real local infrastructure thing? So I guess what I'm suggesting is like there's an inherent two sides of the coin of like, we're putting on these DERs in critical areas, they're delivering all this infrastructure value. On the other hand of, well, we need to be interconnected in 6 weeks. And I think that we should maybe accept as a community that like inherently the value we're going after, which is a totally legit value, is related to the non-trivial task of them integrating your asset to the distribution system, from an interconnection, from, you know, I also think you can't, you know, separate operations, you know, kind of, and then these are merging. You know, we're hearing more of like the flexible interconnection concept, which in some places just means like we're going to do something for like to get one data center online. But then in a number of markets, that's kind of a catch-all, frankly, not in California as of yet, for any number of things on the distribution grid that we're going to take a non-static, like dynamic view. You know, and basically what it boils down to is like, well, if we can curtail you a few hours a year, we can interconnect this and then use this. Whereas like traditional interconnection would look at it and say, you fail. So I think there's a lot of work to do, but to try to summarize and maybe to suggest a little bit of a paradigm shift from the industry point of view is that like, we should acknowledge that like we're delivering these really critical resources that the grid's going to be run off of. There's legitimate things the utility. We should also continue to advocate and push back against the utilities, as we certainly do. But there's, you know, it's kind of a new paradigm for a lot of people to start really kind of changing the way we operate these grids, and that flows down to interconnection. So,
Well said.
Yeah, I think interconnection sort of boils down to like better transparency, better certainty on timing, and better certainty on price, right? And so there's there's no one like single bullet to fix the interconnection. I think there's a lot of things that can help. One is just better data. Like Hawaii was able to connect, I don't know, 2 or 3 times as many more behind the meter systems once they got better data about the actual characteristics of their distribution grid, as opposed to charging people zillions of dollars to upgrade the grid. There's lots of, requiring the utility to comply with its own tariffs and like meet its deadlines. We got a law passed in Colorado that actually allows the commission to impose fines on the utility if it doesn't hit its deadlines, right? So utilities hate fines, even if they're like meaningless in the overall scheme of how much, you know, they could pay the CEO. Flexible interconnection is another big one, I think. Like the Texas Connect and Manage approach, you know, it sort of puts the onus on you as a developer to figure out, okay, how much curtailment can I accept, and can I make this project worthwhile and, you know, economic? And at the transmission level in particular, another one that we're really interested in is what they call surplus interconnection service. So how easy is it to add storage to an existing grid asset, whether it's a solar system or, you know, gas plant or what have you, if you can keep the sort of balloon or the bubble the same size and provide more capacity out of it, it should be easy.
Let's make one more comment. Yeah, like it does seem, and like we're part of, let's say, like advocacy in California. It seems like in the like larger DER sector, frankly, to diagnose where it's working, it's where the state or there's a program that really acknowledges the value, whether it's New York VEDR, whether it's Illinois, whether it's, you know, what just got passed in Minnesota, other places, and somehow they're able to make the interconnection work in those states. And where there's not such a commitment, like let's say in California, the CPUC, again, to be, you know, well fair, is, you know, basically says we just don't agree on principle that the DERs have value. We think they're a bad deal. And, even though utility tariffs say certain things, like the lack of success and just insane treatment that we're getting from the IOUs in California, it's like we're continuing to try to make a breakthrough, but like SDG&E is telling us that like your 2 megawatt projects need to go to the transmission cluster, and like that's the only thing, like in like no, for sure that's what has to happen. And so like I guess we're continuing to advocate, but it does seem like if maybe downstream of like, yes, we agree we need to do these projects from like kind of a regulator point of view, that seems to lead to better interconnection outcomes.
I completely agree, and I also agree that California is a terrible place to do business as clean energy these days, right? Particularly as DER. The governor hates DERs. I don't know why. The NEM policy, the PUC is terrible. Everything's bad in California with respect to DERs, and like intuitively you'd think that okay, you can hate distributed solar because there's a lot of it, but really you should like distributed storage. You should like storage, storage is like bacon. Everything's better with storage, right?
Exactly. It solves so many problems all at once. And I think one other interesting piece, right, is California in particular, but so many grids are so aged, right? Their infrastructure is so far behind. I think the average life of a transformer in the state of California, I heard, I saw this somewhere, was the average age was past end of life. So like everything needs to be upgraded. So if you can also use that and connect it with deferred maintenance, I think that's when storage really, and I saw that recently in another state where they were able to basically get a bunch of I think it was Pennsylvania, maybe it was like a bunch of storage deployed with utility funding, because they were actually going to have to spend X number of millions of dollars on upgrades that they were not needed now because of the storage. So to me, if you can somehow tie all that together, it's kind of the perfect storm.
Somebody figures out how to tie together the timelines for deferring distribution projects and deploying DERs. Like that's the trick to getting that avoided distribution value. That's hard. Like New York sort of does it, and they do it reasonably well. But I think that's one of the tricks, is the timelines don't always match up.
Well, hopefully, continued disruption in the space will force change. We've got we're gonna get one more topic that I want to cover, and then we're gonna open it up for Q&A. So think about questions you might have for this audience. The last topic I want to cover is around equipment selection and the tech stack within a battery storage system. So that's something, obviously, Gridvest that we do. That's our whole thing, is finding which battery system, an inverter, and a microgrid controller, and EMS, and balance of system is going to work together. My colleague Liam O'Brien back there is our senior engineer who spends a lot of time thinking about that. And that's where we see a lot of projects fail. Basically, even if they check all the other boxes and get their interconnection, they might have the wrong tech stack that ends up throwing the whole project into basically disarray. And I think most people think that batteries are just, you plug them in, just kind of like solar-esque. The reality, obviously, is it's much more complex, and no one's really figured it out. And there's no turnkey solution. There's no microgrid in a box, at least for commercial, industrial, and utility. Residential is a different story. But so the question I want to ask, kind of hear from each of you, is how are you navigating that for your, like in your case, for your project, Sam, and then Adrienne, how are you helping your customers navigate that? And Sean, I'd love to hear you kind of more at an industry level, like how can we improve that process? How can we create some more standards? How can we just get more of a speed up that process for deploying equipment that works? So I'll start with you, Sam.
I can't say that we figured it out. It's top of mind. I mean, I think I'll start by answering that question by talking about the requirements that are on sort of community scale batteries, which I think are really important and are different than other seemingly similar profiles. So generally our projects, and we're most active on the West Coast, and in particular the Pacific Northwest. We have kind of a whole fleet of assets that are contracted with utilities up there, and these are basically under full toll contracts. So it's a different business model than what we heard on the last panel. We show up with our battery in it, good part of the distribution grid. They, for 20 years, face a fixed price, and then they are able to dispatch, which is essentially a pretty simple daily cycle to reduce their local peak. So that's all great, but so the availability requirements is kind of one of the key contract terms that they're putting on our assets are like 98% on a monthly basis. So that's like extremely high. That's actually higher than most transmission system full tolls, but you would think the opposite. Like, I think that's again a reflection of like, yeah, you know what, this came from our distribution engineering team. Like, they're going to rely on your asset. Like, we cannot have this thing go down in September when we're going to need it. So I'm bringing that up because I think you're right. We haven't figured it out. I don't think we've figured out like the operations and maintenance, over, I mean, there's like 5 years of batteries being operational at this point. So I would say that our tech selection is really going to kind of flow down from that 98%. Like, this isn't just like you're going to lose a little bit of kilowatt hours of revenue. Like, there's severe financial penalties if you don't. So like, it doesn't have to be the craziest battery. These things aren't doing like, ancillary services frequency. They're not like being run super hard, but they need to be there. That's what their job is. So that's kind of what drives our, kind of trying to de-risk from a tech selection.
Right. And batteries aren't just batteries, right? There's the inverter, the EMS, and all the things I mentioned earlier. So I think that's the other thing people forget. So great point. Adrienne?
Yeah, this is a great jumping off point for us. I mean, really what we do is we take a step back and we really try to understand what is it you want the battery to do, and what are the conditions under which it's going to be operating, and what do you expect to happen when you have a peak? Is it going to shift the load? Is it going to notify somebody? Is it going to disconnect? And so what often happens when people don't have the right tech stack, it's because it's not meeting some performance criteria that either was envisioned at the beginning of the project, or as the project was finally deployed 2 years later, now has become a requirement in order to make that project work and make it viable. So there's a duality that goes on between making sure that the value that you're taking out of the battery is very clearly sort of, the scenarios are laid out and discussed, and then the technology that's put in has the capability to kind of meet those different contexts that are going to be presenting themselves. So, and some of that is some technology is not ready and can't respond as fast or to meet some of the needs. And then being able to do the upgrades, repowering, and some of the other things. So for us, there's a time component in there as well that comes into play.
Yeah, and just communications across all the different systems, right?
Oh,
and communicating with the grid, and communicating with the building if it's behind the meter, and communicating with,
So so just as a case in point, one project, we had a customer come to us. He's like, we're doing a repower. We've got the solar in and we've got the battery in. We went to start the battery up, but we can't get it to start up. And we called the manufacturer of the battery, or the person we bought it from, and they're out of business. What do we do? And so then, we worked with them to replace the inverter, get the controller up, and now that battery is functioning and providing power. And it took us, about 6 months of collaboration to do that. But those are some of the things, around that. It can be something super simple for the tech stack not to work. You've got, tens of thousands of equipment, right? And it all just doesn't work. So that interoperability is super, super important.
Yeah. And that's why my plug is for finding solution, like hardware and software companies that are going to be there to actually support their solutions. So good call out for what New Sun Road's doing.
Yeah, so we are obviously another step removed, right? I'm not selecting hardware or tech stacks, but so the kinds of things that we're looking at are the standards and compliance. So things like cybersecurity and technical standards for inverters, right? We're looking at fire safety standards and trying to ensure that they're both understandable and workable. Things like FIOC and other compliance mechanisms you're going to have to worry about, that they're both understandable and workable, so that whatever product you're buying, you sort of know what it can do and know what it should do in order to work for the grid and for your customer.
Yeah, great. And one request, if you could talk to UL, please, and try and maybe reduce the number of new additions they come out with, because it is incredibly hard to keep up with.
Point 2 and point 3.
And 9540A and 9540, that happen to be two completely different things somehow. There's just an A in there. So there's a lot of challenges around that I think is maybe an area SEIA could help with. Would be a big ask, I think, for the industry in general, because battery manufacturers, especially non-American battery manufacturers, are very frustrated with, like, they just spent all this money getting all the certifications and now it's out of date. And now a city like LA understandably wants the best of the best in terms of fire protection and certification. So they're going to say, oh, well, this came out 2 weeks ago, so now we need it. It's like, well, that's a 12-month process to get a battery certified through that, and you have to burn the whole battery through a large-scale fire test. So, yeah, it's a big ask.
It's a fair point.
Yeah. So anyway, that's my complaint. But thank you all. This has been a really great conversation. I want to open it up for questions, and then we'll move into lunch and learn. Yeah. There's no mic, but so just shout it out. I'll repeat it as well.
I'm from Subatomic. First of all, I like the idea of the API and compatibility. So my previous company ran for 10 years. Half of my engineering staff were just on the software layer because everybody else was giving us black boxes and telling us to deal with it. And I had exactly the same issue where it took 2 weeks to get a response from customer service. So a nightmare. My main question though was around finance. So been at this whole week, everyone's talking about AI. It's sucking the oxygen out of the room for a lot of everyone at LPs. Where are you currently seeing that in this market, both from general asset finance lending, so large project lending, but also are you hearing from venture capitalists about where they're looking? Because what I'm experiencing is when you mention the word batteries, like their eyes glaze over and they stop talking about it. Even though we've all heard today, the economics are working, the tech's working, deployments are going up. So I just wanted to get your opinion on that.
Yeah, I can start with that. So as an infrastructure developer, we definitely talk to some venture capital people, and I think I don't quite understand, but maybe identified after a few go-arounds that we weren't really in the VC landscape. And I would say there's kind of this missing middle thing where, so we were lucky enough to raise seed capital that allowed us to sort of fund our development, particularly at our class size. We were able to, if you're going to do 100 megawatt projects, you need hundreds of millions of dollars, just from the very beginning. So we raised, some, kind of good seed round, and that was going. So what we thought was, okay, then we're going to generate value and, whatever, and kind of lead to sort of a quote Series A, let's say of 3 to 5 million. And that essentially doesn't exist. All the conversations you have, at least from our business model, is cool, can you take $100 million? And you're like, no. And they're like, okay, come back when you can. So there's this huge, just missing middle, right? So from as an infrastructure developer, it's, maybe not we're a good profile for VCs. I think that there is kind of a missing middle of, solutions, sort of development capital or whatnot. We ended up finding a partner that basically is going to likely be the long-term owner of our first projects and is providing us sort of capital. But I would say, at a certain point, you're going to want to, raise infrastructure capital as a DG platform. The question is if and when to do that, or if you're able to sell projects. But I would say it's it's a very discontinuous financing environment of this is available, there's a huge gap, then only this kind of thing is available, and so navigating that has been interesting.
Great. Yeah, I mean, my quick response, then I want to get another question or two in, if there are any, is that what we're seeing is just that there's a ton of infrastructure capital, right? Infrastructure investors who are throwing money at this problem, and hundreds of millions of dollars per project or more. And I think the issue is that it's a race to. There's no answer at how to do it with data centers easily, right? And so everyone's trying to design their own system for UPS and having backup power, but also being able to take a small grid connection, make it a big one, or go off grid and build your own data centers, or plug in with natural gas generators and turbines. So I think the problem is that it's all happening very fast, and the technology deployment, how to actually do it, is not very clear. And so there are going to be a few winners and probably a lot of losers. There's a lot of projects that won't probably proceed, but I don't have a direct answer to your question besides the fact that I think what I'm seeing is it's just large infrastructure players who are running the show. I don't see a lot on the VC. To your point, I agree with you that a lot of times people eyes glaze over when you hear batteries. So, but I think it's changing slowly. I think this day, Climate Week and this event in particular is showing that there is a whole world of people who I think are waking up to battery and battery innovation and deployment. So come chat with us after. Is there any other last questions? I think we're almost at time, but would love to take one or two more if there's any thoughts from the audience. Don't be shy. Everyone's hungry, huh? Okay, well, with that, we'll wrap. I guess I want to thank everyone on the panel. You guys are amazing. We'll be here hanging out. Gridvest is sponsoring the lunch, so I hope you enjoy lunch, catered by Nourish by Serena, local catering company. And then I will be hosting a lunch and learn during lunch in this room right behind you, just talking a little bit more about large-scale battery deployments and what we're seeing in terms of some of the things we talked about around tech challenges, around financing the equipment, and also just an open conversation for people who want to have more, kind of get your brains stimulated more around battery storage. So meet me in there in a few minutes and we'll get started. Yeah, lunch is served over there. And again, thank you all for the panelists and great conversation.